Şevket, you have 10 minutes, please.
Good afternoon, everyone. My name is Şevket Bostancı from the University of Şevket. Following Professor Şevket's presentation, that will be quite linked on local basis, actually. My presentation will be about the use of glass fiber in low carbon paste production, and I'll specify my reasons regarding to why I did use these materials in the upcoming slides. And here are the contents of my presentation. I don't want to touch regarding to save some time. First of all, giving you very brief on the background of my research. Nowadays, we get to hear more about SDGs, Sustainable Development Goals by the UN, United Nations. And one of the aspects is reducing the carbon dioxide emissions, and this is not something new actually. However, we are trying to be on international basis, national and local basis regarding to Professor Şevket said, whatever we have got available on national level. However, performance loss is a major challenge, but I don't fully agree with the strength reduction as Professor Şevket also pointed out. That's why in my previous papers I did mention there should be a score board in order to give score for each property. So for the paste, as we replace the cement in order to lower the carbon dioxide emissions, what we can use in order to compensate these strength losses. Fibers are utilized in this aspect in order to compensate this strength loss. However, whether they are effective or not is a question mark. But as we say here, effective approaches, industries aiming to integrate these approaches, they have to be cost efficient at the same time. Otherwise, industry doesn't go for it. And also there's another aspect, circular economy, gaining importance of the circular economy in order to promote the sustainability further, because it's not only the embodied CO2 emissions, it's also the cost aspect. We can persuade industry to go for these approaches. I kept it short as possible, my slides. Here are the materials that I used for the PC, quite straightforward, under the EN 197 standard. And wood ash waste was the waste material in order to achieve low carbon. And I have done previous research on using wood ash in concrete production, but here I did use in the paste, and specific gradings I did use in order to compare with my research earlier. I did see it to 425 micron, and in order to make a comparison, if grading changes, what happens, I did see it to 300 microns. These are quite coarser when compared with Portland cement, but there are some other researches I have been doing. This is only glass fiber today. I have animal hair, and I have polypropylene fiber. In order to cope with all these projects, I did keep the seed sizes quite coarser to extract more materials, to be honest. And PC was replaced by 5 and 10%. That is basically depending on the existing literature, which mostly think that 5% would be the ideal content. And also, I did use 5 and 10% in concrete production, so at least I can have a comparison again compared with my previous researches. In addition to that, I did use glass fiber. One of the reasons, and the major reason actually, amongst the fiber types we use in our university, glass fiber is the cheapest one we have got, and bear in mind, as Professor Şevket also said, we import them from Turkey, and that comes with a cost, and that comes in euros nowadays. In order to keep it on the cost-effective side, I did only use 0.25% of the total cementitious content. Here are the mixed proportions of the cement paste. Bear in mind, water to binder ratios are kept constant, and replacement levels were done on mass basis. And you see the abbreviations on the left-hand side. GF represents the glass fiber utilized mixes. Okay, when I was doing this analysis, that was quite short time, I was going to go for the embodied CO2 emission calculations. So here are the system boundaries. As you see for the glass fiber and wood ash, transportation were neglected. The main reason is I was going to cover that weight for the wood ash, so that's ignored. For the glass fiber, there's no specific route that I have been following actually regarding to how it is obtained. It's obtained from Istanbul, by the way. And same route was followed for the cost aspect. After I did send the abstract, I decided to go for the cost calculations at the same time. Otherwise, it wouldn't be promoting the sustainability. That's why intentionally I left the title as low carbon. So I'll start giving brief regarding to the results and discussion. First of all, as you see, when we utilize the wood ash, fresh properties were lowered. That's basically due to the irregular shape and texture of the wood ash used compared to the PC, and also my colleague, Associate Professor Dr. Taylan, he did some study, microscopic study on the same wood ash, and he has observed similar issues. When we utilize the glass fiber, further friction is increased, thereby significant reductions were observed. However, 300 micron wood ash mixes achieved quite or slightly lower compared to 425. That could be due to reducing the grading may increase the surface area, so require more water. And a similar trend was observed by the flow table results. As we are being challenged by the time, I'm going to discuss quickly. For the strength results, as the strength is a major indicator actually, there is no specific reduction or improvement we did observe as the replacement levels were quite low, 5 and 10%. However, at the initial phase, at 7 days, as expected, strength was reduced. However, over time, 28 days and 56 days, these got compensated and further hydration provided to be through pozzolanic reactions. I suggest from 28 days and onwards, my previous studies suggest that the pozzolanic presence take place at 21 days. When we jump into flexural strength tests, as expected, due to the glass fiber presence, it acted as a bridging effect, thereby improved the flexural values significantly. When we go back to the compressive strength test, nothing specific was observed for the compressive strength, but for flexural, yes, we did observe. And the next slide will be about the porosity. When we utilize the wood ash, it increased the porosity at the very early ages. However, due to pore refinement, which also supported by the strength test values, porosity values were slightly similar or slightly higher compared to the control mix. So there's no really major drawback by the wood ash utilization. When we utilize glass fiber, we observed slight increase at the early ages, but it got compensated at especially 28 and 56 days. As you see also, if we remember the fresh properties, it's quite linked actually regarding to 300 micron seed mixes had lower slump values, thereby it's believed to have more porous structure. That's why the porosity is increased. I want to jump quickly to the next one, sustainability evaluation. How I did do that? Based on the volumes that I discussed, I divide this volume by the given quantities, and I worked out the CO2 emissions and cost per cubic meter. And as you see, 5% and 10% replacement by potash decrease the embodied CO2 emissions by 5 and 10% approximately, respectively. And same applies for the cost. We mostly observe reduction except glass fiber utilization. The reason is we do import this glass fiber from abroad, and it's in euros, thereby the currency rate going up nowadays. But most importantly, I try to make a relationship results show that it's quite comparable and nearly similar, except of 300 glass fiber. So in general, we can say that wait for the fast track construction. We need to wait until 28 days onwards regarding the removal of the formwork for the concrete production. Potash and glass fiber utilization have improved strength significantly. And also another aspect which I did observe also in the concrete production, 425 micron sieve potash mixes at lower precipitation, and this may be due to better dispersion when it is quite coarser, and it's quite challenging when it gets finer. And also investigating potash sieve to 150 micron in my researches. It could give us promising solution for the sustainable production and promotion of the sustainability. And in order to further reduce these emissions and costs, we need to develop a national waste action plan. We could cope with it, especially the taxation on the landfill action, and also we need to promote the use of waste materials. Otherwise, in this